The Amazon rainforest, the largest tropical rainforest in the world, lies in the northern part of South America, with the Guiana Shield to its north. Although deforestation rates are currently low, the area is threatened by mining, logging and agricultural activities, and our study shows that this could have serious consequences for the Amazon and agricultural regions beyond.
Deforestation along the Amazon's southern margin has been quite widespread and well reported in the media. We felt it was important to understand what would happen to the northern boundary if that also became deforested.
Forests have a major role in helping to regulate the climate through the water cycle. They also contain a large amount of carbon, which deforestation is currently releasing to the atmosphere, helping to accelerate climate change.
In tropical areas, although the trees are a dark colour and so absorb the sun's energy to warm the air locally, this is more than compensated for by high rates of evaporation from their leaves, which means that overall they have a cooling effect.
High levels of water vapour in the atmosphere contribute to cloud and rain formation, which also helps cool the land by reflecting away sunlight. The forest's uneven canopy gives a rough surface to the land, which triggers upwelling of the atmosphere locally, also contributing to rainfall generation. So forests affect both temperature and rainfall levels, but how far this influence stretches is not so well known. The tropical rain belt, seen here in green and yellow, is a band of heavy rainfall near the equator, where the northeast and southeast trade winds converge. It brings moist air across the Atlantic Ocean and into the northern part of South America. This rain belt migrates north and south with the seasons, crossing the coastal part of the Guiana Shield twice a year and carrying moisture deep into the continent. If we look at the low-level wind patterns in more detail, during April to September, the winds carry moisture into eastern Colombia and back around the Guiana Highlands, supporting high rainfall levels in this area. Conversely, between October and March, moist air from the Atlantic Ocean is carried over the Guiana Shield and into the Amazon basin. Here, the winds are diverted south by the high mountains of the Andes. This atmospheric river narrows around Bolivia into what is known as the South American low-level jet, and moisture is then redistributed at its outlet across the La Plata River basin to the south. We used a regional climate model to explore what would happen to climate across South America if around 28% of the Guiana Shield rainforest was deforested and replaced with savanna, the alternative natural land cover in the region. We used maps of the Guiana Shield showing zones that are currently threatened by mining-related activities and used these to produce our deforestation scenario. Here we see the historical simulation of monthly average rainfall and temperature on the left and the differences in the deforestation scenario to the right. The upper right image shows that deforestation in the Guiana Shield causes the simulation to be significantly wetter, in blue, west of the Guiana Shield, when the tropical rain band is to the north. When the rain band is to the south, the core Amazon region gets wetter, with drying, in orange, extending southeastwards. The lower right image shows that this drying is accompanied by significant warming south of the Guiana Shield. The simulation also suggests that following deforestation, this area also experiences an increased number of dry months, where a dry month is assumed to have less than 100 millimeters of rain per month. This is the case particularly in July, where 16 out of the 30 months simulated become drier, indicating an extension of the dry season. Our simulations also show that deforestation in the Guiana Shield reduces the transfer of moisture in the southerly direction, especially in the area of the South American low-level jet, by around 4% per day. This leads to a complex pattern of wetter and drier areas across the La Plata Basin between October to March. In fact, the model simulates rainfall increases or decreases by up to 70% in individual months, which could lead to an increased risk of flooding or droughts in particular areas. This would impact agricultural activities in La Plata Basin, one of the largest food-producing areas of the world, responsible for generating around 70% of the GDP of the area.
The study demonstrates how deforestation, even if small in spatial extent, but occurring at the start of an atmospheric river, can alter its flow with changes in temperature and rainfall as far as 4,000 kilometers away.